In this video, I want to take a look at some examples of working with test hypothesis. And again, when I talk about the tests, we're going to only be looking at rejection regions. So I'm going to take that approach now, and I'll come back later and I'll talk to you about the p-value approach. And in a future video, we'll kind of compare the two approaches, and you'll see that the p-values are probably an easier way of doing things, but they don't make sense quite yet. So in this one, I don't know how you say this word, FALE, market research bases charges to a client on the assumption that telephone surveys can be completed in a mean time of 15 minutes or less. If a longer survey time is needed, a premium rate is charged. So obviously the value 15 is very important in this problem. A random sample of 35 surveys. Now when we talk about working with a population mean, estimating a mean, or doing a test for a population mean, 30 or more is what we consider large. So we have a large survey or large sample of 35 surveys, provided the survey times found in the FALE data file. That's how we're going to, actually I'll probably say it different every time I talk about it. Based on this survey, do you believe the premium rate is justified? Assume that the population standard deviation is known to be 4 minutes, tested alpha equal 0.05. So you can see I have already entered the data in the FALE data set. I put that into Excel, and I generated this printout. I went through the menu, and I've shown you how to do this in other videos of how you do a test hypothesis for a population mean. And so what do we want to test here? Well, we have a test of, let's see, 15 is the value that's really of interest. So what do we need? The surveys can be completed in a mean time of 15 or less. If a longer survey time, so we want to see if the mean is a longer survey. We want to test to see if the mean is greater than 15. So that's what we're going to list as our alternative. We're going to do a greater than test. And you can see when I entered the information into Excel, I had to put in the hypothesized value of 15. I had to put in the standard deviation of 4 that was given in this problem as well. The sample size, the sample mean, all these other numbers came from the Excel function or the data analysis that I did using the data. So we want to test to see if the mean is greater than 15. Now the alternative is the thing we want to test. That's going to be the greater than, the less than, or not equal to. It depends upon what you're trying to say in a particular problem. We were looking for longer surveys. That's why we did a greater than test. The null, there's a couple different approaches. You can either write equal, which is what I'm typically going to do. But in this case, you could actually write less than or equal to, and that would be fine. When you're doing a one-tailed test, you can make the other direction. You can put that in the null. Typically, you're going to see me just write the equal to sign in the null, and that way it's very consistent. It's equal to whether you're doing a greater than, a less than, or not equal to. If you want to do the one directional test, if you want to do the less than or equal to when you're doing a greater than, I don't have a problem with that. In fact, there's a little bit of a discussion, a disagreement among statisticians as to the appropriate way of doing that. The end result is I don't think there's a consensus, so either way is fine. The test statistic, this is the formula. This is a z-score part. This is a value I want you to always find on printouts. I'm never going to ask you to do the math. 30 years ago when I taught this class, we needed to do the math. Now we're going to rely on the software to do that work for us. And so the 4 steps of a test, you got the null and the alternative, you got the test statistic. You're responsible for the null and the alternative. That's what drives this printout, right? I needed to know what the alternative was. I needed to know that 15 value so that I could accurately put the value of 15 in my little menu here. And actually, I guess this is a template that I've created for you in the template so that all the numbers can be generated. Now we gotta evaluate that. Is that far enough out there? And whether you call this a T or a Z is sort of irrelevant too. Probably more appropriate to call it a Z in this case because it's a large sample, but that's neither here nor there. We need to do a rejection region. We need to find what is expected and what is unexpected. The rejection region gives us values of the test statistic that are unexpected. And so it starts with, this statement. We're testing at alpha equal 0.05. I was given that here. Any value between 0.01 and 0.10 is fine, but you have to fill in the blank. We reject H naught if. You got to figure out the if, and it all starts with the distribution. So because we're working with large samples, I'm going to draw this picture, and you know that if I'm working with small samples, my picture looks very similar, right? It's a symmetric curve centered at 0. It's how we label this thing. We're going to call this a Z distribution. Now, I need to find the rejection region for doing a greater than test using an alpha 0.05. And so what I'm going to do, when you have a greater than test, we put all alpha in that upper tail. So this probability in the upper tail is going to be 0.05. If we're doing a lower tail test, we're going to put it in the left-hand tail. If we're doing a two-tailed test, we're going to put half in the upper tail, half in the upper tail. But that's the picture. I want this critical value. I want to figure out what this number is right here in the Z distribution as 0.05 above it. Well, we've seen a couple different ways of working with Z distributions in the past. We've seen the cumulative normal curve, which works with the less than or equal to probability. So in this case, this probability would be 0.95. If you have 0.05 above it, you're going to have 0.95 below it. So we could go to a cumulative normal table, look up the probability 0.95 and find the Z value where that occurs. Or we can go to the norm function, actually the norm inverse function. I'm incorrect there. The normal dot inverse, norm.inv, put in a probability of 0.95, and then put in a value of the mean and the standard deviation, and it's going to tell me that, and where's my cursor here, that this value here is the value 1.645. Regardless of which place you go to. If you go to the cumulative normal table, it's the 0.95 is kind of in between the 1.64 and the 1.65, so you have to kind of figure it out. So we're going to reject if our test statistic is greater than 1.645. And so now we go and see where it falls. Well, we can see that our test statistic is that 2.958. You can see I've changed ink colors. It's out here. This is our test statistic, 2.958, and it does in fact fall above the critical value. It falls in what we call the rejection region. We're going to reject if our test statistic is anywhere out there, and so that's a conclusion. We're going to reject. Now, when you reject the null hypothesis, here's what I want you to do. I want you to do three things for me. First thing I want you to do is I want you to state, this is what we're doing. At alpha equal 0.05, we reject. Now, what does that mean? The null hypothesis here was that mu was equal to 15, right? So we have mu is equal to 15, and the alternative was that the mean exceeded 15. So I'm going to write mu greater than 15. And so when we reject, there is sufficient evidence to say we don't like this one. There's sufficient evidence to get rid of the null, and we're going to claim that the alternative is right. Now, the wording here, there's not magic wording. I like the wording that I use, and you're going to see it consistently throughout the rest of the semester. There is sufficient evidence to indicate that, and then everything after that, everything from here over, is going to be what the alternative says using the words of the problem. Mu is greater than 15. There's sufficient evidence to indicate mu is greater than 15. The average time to complete a survey exceeds 15 minutes. That's what it means in the context of this problem. If we were to fail to reject, we're not in this case, but in another situation, in another example, we may fail to reject. What we'll say in that case is we fail to reject, and the only thing that's going to change is this word right there. When you reject, there's sufficient evidence to say the alternative is true. When you fail to reject, there's insufficient evidence to indicate that the alternative is true. And so you got to see what's your conclusion. Are you rejecting? There's sufficient evidence to say the alternative is true, but say that in the words of the problem. If you're failing to reject, there's insufficient evidence to say that the alternative is true. We're not going to say the mean is, or that the null is true. We're not going to say the mean is equal to 15. We would say there's insufficient evidence to indicate that the average time to complete a survey exceeds 15 minutes. That's what a test is. It's a 4 steps. Identify the null and the alternative, find the test statistic on the printout, get the rejection region, state your conclusion. Rinse and repeat. Let's take a look at another example. So let's come over, let's see, I've lost my cursor, there it is. Let's go here, whoops. Apparently I'm having trouble. All right, how long does the average customer wait in line pumping gas? You know, when you go to the gas station and they have those little videos that are on the pump, how long should those videos be? If they make them too long, we're going to be finished and we're going to leave. If they make them too short, we're standing there, they're wasting their advertising time. So how long does a customer wait? Marketers use this time to advertise products while customers fill up on gas. The marketing videos are 5 minutes in length. A sample of 120 gas customers found an average time to fill up at the pump to be 4.7 minutes, and the standard deviation was 1.5. Test to determine if the average time to pump gas by all customers is less than 5 minutes. If it's less than 5 minutes, those 5-minute videos are too long. You're missing the end. And so they're really interested in that 5 value. We want to test to see if the mean is less than 5 minutes. So we're going to do this test. what we want to show is the alternative. We want to say the mean is less than, and you got to figure out, is it less than, greater than, or not equal to? Well, here I made it really easy for you, right? Test less than 5 minutes. We're going to put the equal to in the null hypothesis. Again, based upon what I said in the last example, what's my other option here? Well, if I'm doing a less than test in the alternative, I would do a greater than or equal to test in the null. Again, moving forward, I'm probably just going to use equal signs here to make it really consistent. It means the null is always going to have an equal component. The alternative is going to be the one you have to think through. You can see on the printout over here, I put in the value of 5 as a hypothesized value. We weren't given a standard deviation in this case, so we're going to use the unknown standard deviation approach. So the software, the little spreadsheet, it took a look at how many customer times I had. The average of the 120 was 4.7. The sample standard deviation was 1.5. And you can see that the test statistics given right here, and that's what I'm going to identify next. The test statistic is a negative 2.191. Again, whether you call this a T or a Z is irrelevant. Negative 2.191 is the value that we're going to use for the test statistic. And now we got to go and do our thing again. So we're going to come over to the next page. Let's take a look at a rejection region. We're going to reject H naught if. Now this time, again, large sample, I'm going to consider a Z distribution. I'm going to come in here. I'm going to put the value 0. What do? I have an alpha of 0.025. Where does it go? Where does it go in a less than test? Well, it goes over here, of course. I'm going to put 0.025 in this tail out here. And I'm going to find the cutoff point, the critical value, the tabled value, I don't care what you call it, that equates to a 0.025. So go to your cumulative normal table, look up the 0.0250 probability, or go to your normal inverse function, put in a probability, the less than or equal to probability of 0.025, and we're going to reject if our test statistic is less than, when you look that up in the table, you get the net value, negative 1.96. Make that a negative 1.96. And so now let's take a look. Where does the negative 2.191 fall? Doesn't it fall out here? Doesn't it fall in the rejection region? We're going to reject if our test statistic's over there. Our test statistic is right there. So again, I gave you an example where we do have evidence. So at alpha equal 0.025, we can reject. What are we saying? We're saying mu is less than 5. There is sufficient evidence to indicate that. And here's a hint for you. At 0.025, we reject H naught. There is sufficient evidence to indicate that. Copy and paste. The average time to pump gas by all customers is less than 5 minutes. I use slightly different wording, but basically that's what I want to say. The way these problems typically work is I give you a story that's got words, right? Where is my cursor? Here it is. There's words. You take those words, and in the last screen we said, oh, we're going to test mu is less than 5. We reject in this case, and we want to say mu is less than 5. And so basically take those words and put them back here. There's sufficient evidence to indicate that the average time to pump gas by all customers is less than 5 minutes. That will work too. The average time to fill up on gas at the pump is less than 5 minutes. Either works fine. It's an indication you know to reject. You know that you're stating your reliability level. When you say alpha is 0.025, you could just as easily say we're 97.5% confident. Again, if my test statistic, instead of being a negative 2.191, what if my test statistic fell here? What if my test statistic fell in the, didn't fall in the rejection region? I'm going to say the negative 2.191 falls in the rejection region. We're able to reject H naught. But what if it was a negative 1.7? What was a negative 1.91? Ooh, it's close, but it would fall over on this side. It doesn't fall in the rejection region. If that was the case, at alpha equal 0.025, we would fail to reject. Not the conclusion that we got in this problem, but I'm just putting that out there as a possibility. There is insufficient evidence to indicate that the average time to fill up on gas. Everything else stays the same. When you reject, there's sufficient evidence to say the alternative is true. If we were to fail to reject, which we're not in this case, we'd say there's insufficient evidence to say that the alternative is true. And that, my friends, is a test hypothesis using rejection regions. All right, now the next step is to probably take a look at that other technique, working with p-values. So take a look at that, and then I'll come back and show you how they work together. So long.